welcome back. Our next topic is about characteristics of sound. You hear different types of sound but are easily able to identify them. You can easily differentiate between a male voice and a female voice. Again, you can distinguish between a note produced by a sitar and that produced by a flute or a drum. The characteristics of sound enable us to distinguish between various sounds. Two important characteristics of sound waves are loudness and pitch. So let us analyze these two characteristics. So children, we are discussing about the characteristics of sound, and we are very familiar of different varieties or kinds of sounds every day. And of course, we can distinguish or differentiate between different sounds produced by different objects, right? So what is the reason for that? What is the difference made by the sound waves? So it is the two characteristics which makes the sound different. They are the loudness as well as the pitch. So let us analyze what is the characteristics of sound. First one is the loudness. The degree of sensation produced by or produced in the ear by a sound is called its loudness. Okay, how much sound that we are getting in our eardrum, that is the degree of sensation produced in the ear by the sound. So it is known as loudness. Okay, you can distinguish a loud sound from a soft sound on the basis of its loudness. Okay, thus you can also say that loudness of the sound is its characteristic due to which we are able to distinguish between a loud sound and a weak sound. So loudness is something related to that of the soft sound as well as the loud sound. Okay, so let us take a look at what are the characteristic of loudness. Okay, first one is that loudness mainly depends on amplitude of vibration. See, in the previous class we have discussed about what is amplitude, right? Amplitude is nothing but it is the maximum displacement of a wave from the mean position. Okay, so whenever the greater the amplitude, then louder is the sound. So first characteristic of loudness is that loudness mainly depends on amplitude of vibration. Okay, when you whisper, you use your very less energy and amplitude of vibration of your vocal cord is small. When you shout, you use more energy and amplitude of vibration of your vocal cord is large. Thus a large sound is produced. See, whenever you are in a class, suppose you are in a class, so you will not speak to your friends. Okay, so if you want to talk to your friends, you will use your low voice, isn't it, when you are in a classroom. So you will use your less energy and the amplitude of vibration of your sound will be also less. So there will be a soft sound. But in the case when you are shouting to someone, what happened? We are using more energy and of course the amplitude will be also greater. So greater the amplitude, louder will be the sound. Okay. Next one, loudness depends on the area of vibrating body. Larger the area of vibrating body, louder is the sound. A large drum produces a louder sound than a small drum. That is also a familiar thing. When we are taking a small drum and a large drum and we are beating onto it, what happened? We can observe that the sound produced by the large drum will be greater than the sound produced by a small drum. So it is due to the loudness depends on the area of the vibrating body. So the area increases, loudness also increases. And next point is that loudness depends on the distance between the source of the sound and the listener. As the listener moves away from the sound source, the sound heard by him becomes fainter and fainter. Okay, it is also very, very familiar to you. See, when an alarm clock is just beside you, we can hear the alarm clock or the sound of the alarm clock very, very louder. When we are keeping the alarm clock on a distance or more than 2 or 3 rooms, okay, so what happened? It will be fainter. right? So it shows that when the distance between the source of the sound as well as the listener is greater, then loudness will be lesser. Okay. For example, when we are sitting in a class of having 100 benches, so the first bench students will hear the sound of the teacher louder, but to the student who is sitting at the last bench, he will hear the feeble sound of the teacher. Why? Because the source of the sound and the listener is far apart. Okay, so the loudness depends on the distance between the source of sound and the listener. Okay. Next one is an activity to show that the loudness of sound increases with increase in amplitude of vibration. That's a very familiar activity. You can just go through the textbook and read it. The conclusion is that you will observe that the loudness of sound produced increases, and now the ping pong balls also jumps higher, when which shows that amplitude of vibration is larger. Okay. And figure 6.10, which shows the wave nature of soft and loud sound. See, when we are having a wave or a sound wave having the small amplitude, it will produce a soft sound. And in the second figure, it is a sound wave with large amplitude, which shows the loud sound. Okay, it is the loud and weak sound produced, and it is the graphical representation of the sound waves. Okay, so that you have to study. And next characteristic of the sound wave is the pitch. Okay, so let us see what is pitch. The characteristic which determines the shrillness of a sound is called the pitch. A sound of low pitch is called a flat or a hoarse sound, but a sound of high pitch is called a sharp or a shrill sound. Thus, you can say that the pitch of a sound is its characteristics, due to which we are able to distinguish between a shrill sound and a hoarse sound. Okay, so pitch is a characteristic which determines the shrillness, that is, whether the sound is high pitch or a low pitch sound. Okay, so that characteristic of sound is known as the pitch. Okay, the low pitch is known as flat sound, and the high pitch sound will be called as the sharp sound or the shrill sound. So pitch help us to distinguish between the sharp sound or the hoarse sound. Okay. The voice of a crow is flat, but that of a cuckoo is sharp. Again, you can distinguish the sound of a grown-up man from that of a child on the basis of pitch of their sound. Pitch of a grown-up man is less than that of a child. Pitch of a sound chiefly depends on its frequency of vibration. We have discussed about what is frequency of a sound. Frequency is nothing but the number of waves per unit time. Okay, so when the frequency increases, pitch also increases. That is, the sound will be high pitch sound. Okay, when the frequency is less, it will be a low pitch voice. Okay, so pitch mainly depends on the frequency of vibration. So children, the loudness depends on three factors. First one is that it depends on amplitude, and second one, it depends on the area of vibration, and third one, it depends on the distance between the sound source as well as the listener. And the second characteristic of sound wave is the pitch, and the pitch depends on the frequency of vibration. So these are the important characteristics of sound wave. Okay. So here is the graphical representation of high pitch sound and low pitch sound. So in the first figure, you can see that the frequency will be smaller, which means when we are taking a particular area, the number of waves will be less. So it will be called as or we can call it as less frequency. Okay, so it is low pitch sound. And in the second figure, you can see that per unit time, there will be more waves. Okay, so we can call it as high frequency and high pitched sound. Okay. Next one is about the speed of sound. In the previous chapter, light, we have discussed about the speed of light, isn't it? So here we are discussing about the speed of sound. We know that sound needs a medium for its propagation. Sound travels with a constant speed through a given medium. The speed of sound in air at the room temperature is 15 degrees Celsius is 340 meter per second. However, with change in temperature, speed of sound in air changes. That's the important thing. See, when we are taking the room temperature, the speed of sound will be 340 meter per second. Okay, with the change in temperature, the speed of the sound changes. Okay, and in chapter 4, you have read that the speed of light in air is 3 into 10 raised to 8 meter per second. So it is clear that the speed of sound is extremely small as compared to the speed of light. Okay, so that's a very important thing you have to underline and study it very nicely. That is, the speed of sound is extremely small as compared to the speed of light. When we are on the ground of these statements, we can observe these followings. That is, when an army personnel fires a gun at some distance from us, we see the smoke of the gunfire earlier and listen the sound of the fire a little later. Why? Because the speed of sound is lesser or smaller than that of the speed of light. So the light travels initially or first, and only after that the sound will produce. Okay. And next one, during rainy season, the flash of lightning taking place in space is seen earlier, but sound produced due to thundering of clouds is heard after sometimes. This is also on the ground of that the speed of sound is smaller as compared to that of the speed of light. Okay. For the estimation of speed of sound in air. To estimate the speed of sound in air, we select two hills separated by a distance of few kilometers in a hilly region. Let A and B be two hills of almost same height separated by a distance S. The experiment is performed during night time when no bright light is present. So this experiment is done in order to find the speed of sound in air. Okay. So let a person situated on hill A fire a gun. Another person should stand on hill B with a stopwatch in his hand. As soon as he sees the flash of firing of the gun, he should start his stopwatch. After some time, when he hears the sound of the gunshot, he should stop his stopwatch. In this way, he measures the time t between seeing of flash and hearing of sound. So what we are doing is that the person B who is in the second hill, he should start the stopwatch when he is seeing the fire. Okay, and he should stop the stopwatch when he hear the sound. So the time between the flash, that is the seeing of flash, and that of hearing of sound is taken. Okay, and we have measured the distance between the two hills also. So obviously the speed of sound nu will be equal to distance covered divided by time taken. So the time taken is between seeing of flash and that of the hearing of sound. Okay, so distance here it is taken as S, and the time taken can be taken as T. Okay, so S by T. So experimentally determined value of speed of sound in air is 340 meter per second at a temperature of 15 degree Celsius. Okay, so this is how we can estimate the speed of sound in air. And next one, speed of sound in different media. Speed of sound is the least in gaseous media. That is very important point. That is, the speed of sound is least in gaseous media. Speed of sound in gas depends on its density. For a lighter gas of less density, speed of sound is greater. Okay, when density decreases, the speed of sound increases. Okay, speed of sound is maximum in hydrogen gas, having a value of 1284 meter per second as compared to 331 meter per second in air at 0 degree Celsius. See, the speed of sound in air at room temperature, that is 15 degree Celsius, is 340 meter per second, and which is in 0 degree Celsius it will be 331 meter per second. Okay, hydrogen has the maximum speed of sound. And next point is very important. Speed of sound in liquids is more than that of the gases. Okay. For example, speed of sound in water is 1402 meter per second at 0 degrees Celsius. It means that sound travels more than 4 times faster through water than air. Speed of sound is maximum in solid. For example, speed of sound in steel is 5941 meter per second. It means that sound travels 15 times faster than through steel than through air. To show that the sound travels faster in solid metals than in air, you can perform the following activity. So there is an activity in your textbook. You can go through the textbook. Okay, so the speed of sound is maximum in solids and is less in liquids and very least in the gases. And the speed of sound in gases depends on the density of the gas. Okay, so these are the topics for this class. Everyone, please go through your textbook, read nicely, understand all the concepts, keep safe in your home, keep watching. Thank you.